Okay, it's time to talk about our last section from chapter 4. This is section 4.6 and deals with what's called an arithmetic sequence. So that's not arithmetic out there. That word is arithmetic. So we're going to start off with our first objective. Let's try to understand what an arithmetic sequence is and how to come up with the next few terms. So we have a definition here, as everybody can see. If you have at least three numbers listed and they follow a pattern of adding or subtracting the same value over and over again, that's called an arithmetic sequence. If the pattern consists of multiplying or dividing, or a combination of adding, subtracting, multiplying, and dividing, then it's not considered an arithmetic sequence. Now, the pattern that establishes the sequence is called the common difference. Like, for example, in this sequence of numbers, if you add 5 over and over again, that's called your common difference. And that's how you get your sequence. Let's take a look at some examples. So, can everybody try to identify what the common difference from this pattern is? And by the way, this is an arithmetic sequence. Okay, so let's see if anyone was able to figure out the pattern. Now, the common way of denoting the common difference is to use the letter D. That's the symbol we'll use for common difference. So what is it? What's happening as we move from one number to the next? Now, if you ever have trouble figuring this out, there's a shortcut. And it's kind of like our slope formula. Remember how we have the y2 minus y1 or x2 minus x1? So if you were to take two terms from your sequence, let's see if I can get this darn thing to behave. I'm not sure it's going to work for me. There we go. And what I'm going to do is I'm going to focus on two of these terms. And what I will do is I will subtract them in opposite order or reverse order. So watch this. I'm going to start with, struggling here. I'm going to start with the negative 14, and I'm going to subtract the negative 7, which is like negative 14 plus 7. The answer is negative 7. That should be my common difference. I can even try that with another pair of numbers. What if I tried those two? I think it'll work. Second number minus first number. Look, it's the same thing. I could have even tried it with the third pair of numbers over there. Negative 28 minus negative 21. There we go. See, I'm getting the same thing every time. So that's my common difference. What about the next three terms? What would they be? Well, what I would do is I would just keep going. And what I would have to do is just keep subtracting 7 each time. So what would that be? Well, negative 28 minus 7, negative 35. Negative 35 minus 7, negative 42. Minus 7, negative 49. Want to do that on my calculator? Start with -7. Press enter. Tell it to do the pattern. Watch this. -7. And start pressing enter. There's -14. There's -21, etc. Your calculator is built to do sequences. All right, I want everybody to try 1 and 2. Okay, number 1, what is the common difference? What is this value? What are you doing over and over and over again? Well, I don't know if it's obvious to you or not, but it looks like we are increasing by 12 each time. So the common difference is going up by 12. So what if you keep adding 12 over and over again? Next 3 terms. You can use a calculator for this or just figure it out, however you want to do it. Think of 36, 48, and 60. Didn't really need a calculator for that. All right, let's go down to number 2. What do you think? If you got number 2 done, why don't you try number 3? All right, now maybe this one's not as obvious to you. So what I will do is I will take a pair of numbers, and I'm going to go to my calculator. What I'm going to do is I am going to subtract the second number minus the first number. Okay, I get 0.4. You could try it for more pairs, but I'm thinking 0.4 is a common difference. And that's a positive number. Okay? That means that I must be adding 0.4 every time. Okay? Now, what I could do is I could go to my calculator and get this done, or do it without a calculator. It won't matter. Put your first number in and press enter. Then tell the calculator what the pattern is. Add 0.4. Is that the next number? Yes. Is that the next? Yes. Is that the next? Yes. Or just start adding 0.4 to your numbers. So I think my next 3 numbers will be those. 1.8, 2.2, and 2.6. 1.8, 2.2, 2.6. All right, on to number 3. Can you tell without a calculator? How are you increasing every time? I can. Looks like I'm adding 4. So the common difference is adding 4. Can you extend this pattern without a calculator? Probably. 24, 28, 32. Okay, that part's done. That's how you understand now what an arithmetic sequence is. You understand the common difference is the pattern, and you can extend the pattern. What if we were to graph an arithmetic sequence? I wonder what that would look like. So if I were going to do this, now you don't actually have to graph this. I want you just to watch what happens. So if I were going to graph this, I think what I'll do is I'll make my x-axis the terms of a sequence. So this is the term number. Okay, and then over here on the y-axis, I think I'll make that my values. So I think I'll go by 2s, 2, 4, 6, 8, 12, 14, 16, 18, 20, etc. So these are the values. So I'm going to go ahead and graph these as an ordered pair. So I'm going to graph this first number. So the first number is 4. So watch what I do. I'm going to put a point here. I'm going to say my first number of the first term number is 4. See how I did that? Now I'm going to graph that next number, and that is an 8. So my second term, see I'm under the 2 there, is an 8. Now I'm going to graph a 12. And that's the third term of the sequence. So I go out here to the third term, so I've got a mark for that. I go up to 12. Do you see what's happening? What if I graph the fourth term, which is a 16? Fourth term location would be here. 16 is here. What do you notice about this picture? Okay, if you said that this picture looks like a line, I would agree with you. So the conclusion is what? The conclusion is that an arithmetic sequence is linear. It is a line. And the common difference is actually your slope of the line. Very interesting. Does that graph represent an arithmetic sequence, everyone? The answer to this question appears to be yes. Those points are in a line. That must be an arithmetic sequence. You might even be able to tell what your common difference is. Can you find the slope of this line? You probably can by counting squares or by looking at these numbers. Does it look like you're going down by 3? It sure does. Every square is 2 units, so that's actually going down 3 and over 1 if you think about it. So yes, and the common difference here is -3. What about this picture? Look at it carefully. Is that an arithmetic sequence? The answer is no. These points seem to be in a curve. This is something completely different. So I can't even classify what a common difference would be in this. I'm going to say no. It could be something else. Maybe we'll study that later. Okay, now it's time for your homework.